Good day, everyone. Today, I am going to solve two problems on limits and two problems on differentiations by applying the symbolic Python. To start with, we are going to input our code. From SymPy, we are going to import all the functions. All the functions is represented by this asterisk. And SymPy defines as a Python library for symbolic mathematics, or what we call the module. To initialize, we are going to put init underscore printing and close parentheses. Also, to initialize the variables we are going to use later on, we are going to use x is equals to symbols parentheses codes x, and there we go. We have the code in order for us to solve the problems later on. And for the problem number one on limits, I'm going to use the function L1 is equals to, let me put the fraction first. L1 is equals to fraction, there we go. L1 is equals to the exponential of x minus the exponential of negative x over x. To display the function, we are going to put L1. And to display the limit, we are going to put the uppercase limit of L1 as x approaches 0. And there we go. We have the problem limit of exponential x minus the exponential of negative x over x as x approaches 0. To solve for the value of this limit, we are going to use the lowercase limit of the function L1 as x approaches 0 is equal to 2. Remember that the lowercase limit is used to solve the value of the limit, and the uppercase limit is used to display the expression of the limit. And in this problem also, we have used the L'Hopital's rules. For more information, L'Hopital's rule is used to evaluate weird limits that result in indeterminate forms. Okay, let's move on to the problem number 2. And for the function of my problem number 2, I am going to use L2 is equal to, let me put fraction first, is equal to 1 minus 2 multiplied to the cosine x, of x, excuse me, of x over pi minus 3x. 3x. And we are going to display the function, and then we are going to display the limit, again the uppercase limit of the function L2 as x approaches pi over 3. And then we have the problem limit of the 1 minus 2 multiplied to the cosine of x over pi minus 3x as x approaches pi over 3. To solve for the value of this limit, again, we are going to use the lowercase limit of the function L2 as x approaches pi over 3. And there we go. The value of this limit is equal to negative square root of 3 over 3. And let's move on to the differentiations. And for the differentiations, we are going to solve problem number 1. Problem number 1 is equal to y is equals to the square root of x multiplied to the ln, or what we call the natural logarithms, or the log of x, and we're gonna run the function. There we go. And to display the derivative, the same with the limit, we are going to use the uppercase derivative of the function y. And there we go. In order to get the derivative of this, we are going to use diff of the function y with respect to the variable x. And there we go. We have ln of x over 2 square root of x plus 1 over the square root of x. And for the problem number 2, we have y is equal to the square root of 4 minus 9 multiplied to the ln of x to the power raised to the power of 4, and y to run the function, to display the function. And again, to display the derivative, we are going to use the uppercase derivative of the function y with respect to the variable x. And to solve for the derivative of this, we are going again to use the diff of the function y with respect to the variable of x, or we can say the diff of y. And there we go. We have the derivative negative 36 over x. In this lesson, I have learned many things. First and foremost, I have learned how to apply symbolic Python on solving problems of limits and differentiations. Also, I have learned some functions and operators, especially the double asterisk, which means raised to the power of. Also, I have learned the meaning of ln, or the log, which means the natural logarithm. Also, I have learned the L'Hopital's rule, which I have used in my problem number 1 on the limits. That will be all. Thank you.